Welcome back to another video brought to you by ISCA Engineering. In today's video, we will be talking about single-phase alternating current motors. We will cover the different types such as the split-phase motor, split-phase capacitor motor, shaded pole motor, and universal motor. This video is a continuation in the motor control and systems series. If you haven't watched any of the previous videos, I highly recommend watching those before continuing this video. Before we dive into the video, if you are not yet subscribed, then please hit the subscribe button, like the video, and leave a comment. Also hit the notification button so you won't miss any of the new videos uploaded. Let's get started. Single-phase motors can be found in homes and in business appliances. Single-phase induction motors operate on the principle of induction, just as a three-phase motor, except for the fact that they are not self-starting. They require an auxiliary means of starting, and once it begins running, it produces a rotating magnetic field. They can be started by mechanically spinning the motor and then quickly applying power, but they normally use some sort of automatic starting. They are classified by their start and run characteristics, and these motors can be found in three basic types: the split-phase capacitor, and shaded pole. The split-phase motor uses a squirrel cage rotor that is identical to that in a three-phase motor. They consist of two windings, one being the main winding and the other one being the auxiliary start winding, which is displaced in the stator 90 mechanical degrees from the main winding. The start winding produces a phase difference to start the motor, and when the motor reaches about 75% of its rated full load speed, the start winding is disconnected from the circuit by either a centrifugal switch or electronic solid-state switch. In the example provided, when the motor approaches its normal operating speed, the centrifugal force overcomes the spring force, allowing the contacts to open and disconnect the starting winding from the power source. The motor will then continue running through the run windings. These motors are simple in design, which makes them inexpensive and can be found in applications such as fans, blowers. Split-phase capacitor motors have a capacitor connected in series with the start winding, which creates a phase shift of approximately 80 degrees between the start and run winding. This is substantially higher than the split-phase motor and therefore results in a higher starting torque. Like the split-phase motor, the capacitor start also has a starting mechanism, either with a mechanical centrifugal switch or a solid-state electronic switch. This disconnects both the starting winding and capacitor when the motor reaches about 75% of rated speed. The shaded pole motor has only one main winding and no start winding or switch. When a single-phase AC is supplied to the stator windings, due to the shading provided to the poles, a rotating magnetic field is produced. The auxiliary winding, which is composed of a copper ring, is called a shading coil. The current in this coil delays the magnetic flux in that part of the pole in order to provide a rotating magnetic field. The direction of rotation is from the unshaded side to the shaded ring. It rotates in only one particular direction and is generally not possible to reverse the rotation unless the motor is wound with two main windings that reverse the direction of the field. These motors are best suited for low-power household applications, because the motors have low starting torque and efficiency ratings. Applications for this type of motor can include fans, blowers, electric razors, hair dryers, and much more. The universal motor is a single-phase series motor which is able to run on either AC or DC, and the characteristics are similar for both AC and DC. These motors are constructed like a series-type DC motor with a wound series field on the stator and a wound armature on the rotor. The field windings on this motor are connected in series with the armature windings. These motors run at lower speeds on AC supply than they run on DC supply of the same voltage due to the reactance voltage drop, which is present in AC and not DC. Both the speed and direction of rotation of a universal motor can be controlled. Reversing the direction can be accomplished by reversing the current flow through the armature with respect to the series field. Varying the voltage that is applied to the motor controls the speed of the motor. These motors are useful in applications such as blenders, vacuum cleaners, and hair dryers, where high-speed operation is desired. This concludes the video over single-phase AC motors. If you have any questions or comments, be sure to leave it in the comments section below. In the next video, we will be looking at AC motor drives. Follow us on Instagram and Facebook at ISCA_engineering_. The links will be provided in the description. There we post content on electricity, controls, automation, and much more. Thank you for watching. See you in the next video.